So far we know how to calculate the distance between 2 points, A and B. But now let us ask ourselves the question, where does the midpoint lie of line segment AB? So we have a line segment AB right there, and we assume that the midpoint lies somewhere here, and we denote it by M. Now, when we ask ourselves the question where the midpoint lies, we're actually asking ourselves at what coordinates does the midpoint lie? That means what are the x coordinates of the midpoint M and what are the y coordinates of the midpoint M. So we need to evaluate both of them. Right. So let us assume that M is actually at the center of the line segment. That is to say that both these distances are equal. And let us draw perpendiculars from M, A, and B such that we get intersecting points D and C. Now, the key thing about D and C are that the perpendiculars are at 90 degrees from each other. That is to say that they actually form 90 degrees at these points. If we look closely, we have two triangles, triangle A, D, and M, and we have another triangle, triangle A, C, and B. Notice that both the triangles, this small one and this big one, share the angle A. What they also share are 90 degrees, which are adjacent to A. And that leaves us with the last angles between both of them to be the same, since the other two are same as well. And by that property, we can say that triangle ADM is similar to triangle ACB. And when I say they are similar, that means their sides are in equal proportion. So we know that AM is half of AB because M lies in the middle of AB. Therefore, AD must be half of AC. And by the same logic, DM must be half of BC. Let me write that down. So we know that AM by AB is 1 by 2. That is, the ratio is half. And by the logic of reasoning, of similarity, we can say that AD is also half of AC and MD is half of BC. Alright, let us try to write down what, let us consider this and let us try to write down what AD and AC are. So, BC here is equal to this height minus this height, which is y2 minus y1, and AC is this distance, which is x2 minus x1. Now, say the point M is actually x sub m comma y sub m, right? That is to say that this height is ym and this distance is x sub m, because this is the origin. Therefore, MD would be this distance, and since we know that this complete height is y sub m, and this height, which is the same as height of A, is y1, therefore MD is ym minus y1. And by similar reasoning, we can say that AD, which is this distance, is xm minus x1. x1 is this, xm is this. So it will be xm minus x1. Right, so we have the key information of the 4 line segments that we had in a formula before. Now let us consider this equation for a moment. So we have AC by 2 equals AD, which implies, let us substitute for VC, x2 minus x1 by 2 equals AD, which is x sub m minus x1. You can solve this out to find xm is nothing but 1/2 times the sum of x1 and x2. Similarly, using the equation BC by 2 equals MD, we should get y sub m equals 1/2 of y1 plus y2. So we have evaluated the positions of the midpoint between the line segment A and B. So the midpoint lies at these coordinates, x1 plus x2 by 2 and half of y1 plus y2 right there. So for a midpoint between a line segment, all we need to know are the 2 points, and we have to take the averages of both their x coordinates and the y coordinates, and that will yield us the position of the midpoint.